Welcome back to the other office hours. Today we're talking about vectors and what we can do with them. To start out, I have this definition on the screen. A vector is a quantity with both magnitude and direction. It can be written in the form v equals v1 and v2, which live in brackets, and we're working in 2 dimensions today. So, let's give you guys a visual example of what to think about when I say the word vector. So a vector is an arrow. We see that most commonly in things like physics, engineering, and also in this course in linear algebra. A vector is an arrow because an arrow has length, or that magnitude that we were talking about, and it also has a direction or some angle associated with the arrow. So there's going to be some angle theta above the horizontal. Alright, now that we've given you guys a visual of what to think about, this arrow, let's talk about notation. So, as we saw earlier, our vector v can be written as v1 and v2, which live in brackets. This is called the component form of vectors, and this is what we are going to most usually see in linear algebra. So v1 is going to be our first component, and this is associated with the x-axis. The v2 is our second component and associated with the y-axis. So, now that notation is out of the way, let's get to the fun stuff, the graphing. So I'm going to drop a graph into our screen here. And then I'm going to write out 3 vectors that we're going to graph together. So let's start with the vector A, which is going to have the components 1, 2. When I say go 1 in the x direction, go 2 in the y direction, you are most likely going to think of drawing a point. The point is 1, 2. We're going to move away from that, and instead, we're going to draw an arrow from the origin to the point 1, 2. That is our vector A. Alright, let's try another one. I'm going to have a vector T, components -3, -4. We're going to go -3 in the x direction and then -4 in the y direction. Again, you're going to want to draw a point there. That's correct, but it's not a vector until we give it the magnitude or the length. So let's draw an arrow from that point to the origin. Alright, a little bit of a wonky arrow there, but there's our vector T. Alright, now finally let's do our vector C. This is going to have the components 0, 5. Since we're not moving anywhere in the x direction, we're just going to go +5 in the y direction and draw our arrow. Do you notice how I started all of these vectors from the origin? That's called our standard position. Turns out, though, vectors don't have to start at the origin. They don't even have to touch the origin. Let's redraw vector A here. That is the same vector A, even though it's not in standard position. Our vectors can live anywhere in space, but when we put them at the origin, that's what we're most used to. That's our standard position. That's what's conventional for us to do, and it usually makes our math a little bit nicer. But our vectors A, C, T, I didn't mean to say A, C, T, but those vectors, they can live anywhere in space that we want them to. One last important note for this slide. The 0 vector is a thing, and it does exist. So a 0 vector is going to be a vector where every single component is equal to 0. This is a vector because, well, its length is going to be 0, and it's also going to have a direction that's basically essentially 0. It's going to look like the point that I just drew on the screen there. A 0 vector does exist, and it's very important for mathematics. Alright, let's move on now. Alright, so here's our first problem. Let u equal 2, 1 and v equal -1, 3. Then, what is u plus v? What new vector will be output from this vector addition operation? So we do have a general strategy that we can use for vector addition. I really recommend that you guys probably memorize this strategy because it's going to be so common and so essential for so many parts of this course. When we have a vector u that has components u1 and u2, and a vector v with components v1 and v2, if we want to add u and v together, our first component will be u1 plus v1, our second component will be u2 plus v2. So we are basically just adding across. Knowing this, let's go try our example problem. So we'll have vector 2, 1 plus vector -1, 3. Doing some arithmetic and some algebra here, we have 2 plus -1, 1 plus 3. 2 plus -1 is the same thing as saying 2 minus 1. Then we have, again, 1 plus 3. This equals 1, 4. So our new output, the vector u plus v, is equal to 1, 4. All right, so I really recommend memorizing this strategy that I've outlined because I guarantee you will see it in the future and this will come up on a homework problem or an exam. All right, here is our next problem. Let vector v equal -2, 5, and a scalar k equal 3. Then we have to find k times vector v to get a new vector output. So when we multiply a scalar by a vector, it's really quite simple. We just put our constant number out front and multiply it by our component form vector. Here we are. Now, what this 3 is going to do, it's actually going to distribute its multiplication. So the 3 is going to distribute and multiply by -2. It will also distribute and multiply 5. So this will turn into a vector 3 times -2 and 3 times 5. Working this out algebraically, we get -6, 15. Therefore, k times vector v is equal to -6, 15. And that's it. All right, and we've made it to our very last problem. So we need to find the magnitude and the unit vector of vector A, which is 6, 8. So again, to remind you guys, the magnitude is going to be the length of our vector, and a unit vector means that this is a brand new vector with the exact same direction as A, but the length of it is only 1. Only exactly 1. So it's exactly 1 unit long, but it faces in the same direction. So let's start with magnitude. I'm going to give you guys our magnitude strategy. We write magnitude with 2 vertical lines on either side of our vector name. So we have our magnitude of A is equal to the square root of A1 squared plus A2 squared. Doing some algebra, we'll plug in the components of our vector A here. And so we'll have 6 squared plus 8 squared. Again, doing some arithmetic. This will turn into the square root of 36 plus 64. Then it will go to the square root of 100, which is of course equal to 10. So the magnitude of our A vector is equal to 10 units. Now, let's go ahead and look at our unit vector strategy. So this is a new equation that you guys probably haven't seen before. Our unit vector strategy is going to be our vector A divided by its own magnitude. So if the original magnitude of A is 10, we're going to go ahead and divide our vector by 10, so we get a length of exactly 1. So we're going to go ahead, take our component form vector, divide it by 10, which is the same as multiplying it by 1/10. I know, a little mistake here, I made that into a fraction, did not mean to. Let's go write our 6 and our 8 in. All right, so this will turn into 6/10 and 8/10. Always try to simplify your fractions, so 3/5 and 4/5. All right, and that is it from me. Thank you guys so much for watching the other office hours. I truly appreciate you making it all the way to the end of this video with me.